Hey guys, welcome to a new video, and although this isn't a Quinboxed, we are going to unbox something real quick, and well, then the rest of the video will become clear. So let me get my trusty tool. For those who follow Quinboxed, you know what this guy is. It's the Rip and Tear tool, and there's two packages here, and they should have basically the same thing, just with two numbers different. Or one number different, actually. But one is one number now, and the other is two numbers. So, okay. That's out of the package. Wow. They went total overkill on the bubble wrap again. I'm just going to cut it, because that's going to take way too long otherwise. There we go. See if I can get it out like this. Yes. You might already be able to see what it is. Well, I guess I'll show you. While we unpack the other one, we'll talk about it. This is an LRS-600-5. Now, the LRS series is, a series of MeanWell power supplies. And the LRS 200 or 150, and especially the 350, is very popular in 5 volt and 12 volt configurations for doing LED lighting, because they offer a very good quality to price ratio, giving you a high quality MeanWell power supply. They are fan cooled, sadly enough. Up until 200 watts the LRS series is without a fan, but above that it does use a fan. But a lot of people use these in their LED boxes and installs and stuff like that, because they provide a very reliable and actually the real output power supply. And as I said, the 350 series is very popular, but they recently introduced a new version in the LRS series. Let me try and get this in the window. Almost. There we go. The LRS-600-5 and the LRS-600-12. So this means it does 600 watt 5 amps. 600 watt 5 volt and 600 watt 12 volt. Now that isn't completely correct, because if we actually look at the specifications on the power supply, it'll tell us what it will actually do. And these MeanWell power supplies, they will do 100% no problem. They'll even do a little bit above that. But so if we look on here, and it might be slightly hard to see, but this one is 5 volt 100 amp output if you're running 110 to 120 volt or 200 to 240 volt. So that's the generic voltages everywhere in the world. And it'll do 5 volt 90 amp if you're running 100 to 110 volts. So if your AC voltage is a little bit lower. 100 amps of 5 volt out of this little power supply. I'm actually thinking it might be slightly thicker than an LRS-350. And, well, let's look at this one. LRS-600-12. It does 12 volt 50 amp. So let me get an LRS-350. I should have one here. Yep. So this is an LRS-350. Oh, I need to focus. An LRS-350-24, so it's 24 volts. But I believe all LRS-350s are the same size. Ah, well, these certainly are not the same size. So let me line up the corners here. It's slightly bigger in regards to dimensions. So it's just slightly longer and slightly wider. It also luckily has a much bigger fan, it looks like. So that's good. But it's also a bit thicker. Okay. So although it's the LRS series and they generally kept the same form factor, these are definitely bigger than the 350s. And, okay. Sure. So let's check. It's set to 230 volt. That's good. My chair is malfunctioning again, so I'm turning into a smaller person. I'll fix that later. There is a new chair actually, but I haven't had time to unbox it yet. Can you imagine? Okay, let's wire these up real quick to the AC side, and then what we're going to do, what this video is about, is we're going to do an actual real-world test to see if these power supplies can actually, well, do what they're rated for. Because I recently bought this, and these are, well, officially they're 150 watt or 25 amp testers each, and I have 5 of them. So 150, 300, 450, 600, 750 watts I can test up to. Now, that isn't really realistic because it depends on the voltage. From what I've been testing, I can run 5 volt, 20 amp through each of the testers reliably. So that's 20, 40, 60, 80, 100. So I can actually load up this LRS-600-5 right up to 100 amps and max it out. And let's do that for like a half an hour long. And then this guy, I'll have to see how much I can draw. So it's 150 watts per tester. So I should be able to reach the 600 watts that this one can do easily also. I'm just going to run both of them, and I'll do a very quick time lapse for you guys up to their maximum rating, and then I'll do a sort of time warp thing of a half an hour, and let's just see if they can actually do what the box or the specification says they should be able to do. Let's first wire up the AC wiring, and I'll do one on video so you guys can see. I almost can't reach the camera anymore. So here is the AC wiring for the 5 volt. Let's do that one first. Now you have live, neutral, and earth or ground. Well, in this case it's AC, so it's generally called earth. So let's do earth first. And it's best to have these fork style connectors on there. So let's wire up earth, then let's wire up neutral in European countries. I live in the Netherlands. Neutral is blue. So make sure they're in there pretty strongly. And then we have live. And we already checked it set to 230 volts, which I have here. So that's easy. Right, so that's in securely. It's not going anywhere. And, well, that's how you wire up AC. That's basically it. I always take just a cheap power cord for like a monitor or a PC or whatever. I snip off one end. I attach at least ferrules, but generally I'll do fork style. And then you can easily wire that up and makes a very, very secure connection. Now, for my testers, as I said, I have 5 testers, and we'll zoom out again. I'm gonna hook this up in kind of a janky way, because, you know, I'll try and keep the screens of the testers in the video, and we're just gonna hook these up to minus. I'm not going to really screw it down yet, because we're going to have to put two cables per terminal for some of these. Minus and positive. There we go. Now, that's kind of janky, but I can't really show you what I want to use this for, because there will be future applications where I need 5 volt 100 amps and 12 volt 50 amps. And, well, that's something I've been developing and we'll be talking about soon. But yeah, so these power supplies would make perfect fits for that, because they adhere to the exact specifications that I need, which is awesome. It used to be that the LRS-350 was the highest version in the LRS series, and you had the SE series. That actually went higher, but well, these are the latest and greatest in the LRS series, so I'm really curious if they live up to the same great quality. As you can see here, they have a little potentiometer with which you can adjust the voltage if it's not exactly right. I don't suggest adjusting it above what it should be. So some people sometimes say if you're getting voltage drop on your LEDs, to just measure what voltage drop you're getting and up the voltage of your power supply. I don't recommend that, because if you do that and then you drop the current or the load, the voltage will rise up and it'll likely spike above what the LEDs can handle now, because, well, without load the voltage gets higher. So then, well, you blow up your LEDs. Okay, so now we're going to kind of double up these wires. So these ferrules have a top side and a bottom side. So I first screw them in with the bottom side up, and I think I should be able to jam it with the the top side together in there. So it's basically flat together. And as I said, this isn't the way to do it. Normally, I wouldn't recommend that. If this is an LED install, I would also highly recommend you use some fuses. Because, yeah, there's a lot of power involved here. But for now, we're going to do this one. All of these wires connecting to the testers are 10 gauge, and I don't remember the metric number for that from head, but I'll post that on the screen. Nope, other way around. Yeah, so these forks are basically flat together and then screwed in. It should give an adequate connection to everything. Last one. Now these are from AliExpress, and of course I will have links in the description. Those are affiliate links. I guess we'll also find out if they're copies or clones or whatever, or real. But those are affiliate links, and if you use those, that helps me out greatly doing this kind of stuff, because these power supplies ain't cheap, man. Come on. Okay, let's first turn. No, wait, I need a display. So, okay, let's wire up the testers real quick, because the testers take in 12 volt separately. So I have 5 12 volt power supplies for that. And they do that to not influence the measurements and stuff like that. So even if the power supply cuts out, the testers will remain online. Okay, so let's power those up. Yeah, some of the screens will be blocked. Oh, this one's not powering up. Oh, right, I forgot to turn one on. There we go. So yeah, some of the screens will be blocked, but basically if you can see that the test is running, that's the main thing here. And you'll be able to see some of the voltages and stuff like that. Power supply is currently off. Let me turn that one on. Ooh, don't hit the mouse. Let's turn that on. Okay, we got a green light. Oh, you can't see it. There we go. We have a green light. And we're seeing 5.9798. Same here, same here. A little bit higher here, 5.1. Maybe a bit better connected cable, I guess. And 593. So that's pretty decent. Now, I'm not going to take too long. I'm just going to go for it. Let's give it 10 amps. Okay. I can't reach the buttons. Let's go for 20 amps. Okay. 30 amps. 40 amps. And this setup isn't the easiest to push the buttons. 50 amps. We're currently drawing, let's see, 278 watts from the socket And well, we're because this is 10 gauge. That's really silicone cable. It's really thick cable. Even drawing 10 amps through it, these are 40 to 50 centimeters long, so not very long cables. And well, we're still getting 5 volt on all of them, so voltage drop is very minimal. And at least the power supply is providing that no problem. And although you can't see, there we go. I guess we're going to skew it a little bit. The fan is actually still off. That's not bad. So I'm going to give this a minute. There's actually a timer also on the displays. I guess you can see. Oh, you can see this one. So it's at 59 minutes right now. But we're only doing 50 amps, so let's say it doesn't count yet. I wonder when the fan's going to go on, because we're still at 50 amps. It's pretty decent. Alright, let's go higher. So that is 20 amps. We're getting a little bit of voltage drop there, but you know, that's expected, even with 20 gauge. So that's, I don't know. I don't care what it is. Let's go full out. So now we're at 90 amps. Fan is still off. 514 watts from the power from the socket. There we go. That's it. We're at 100 amps load at 5 volt. Now, voltage drop is 4.934. That is likely what is in the cable and nothing else. So this power supply is really delivering a very stable voltage. I'll get a multimeter out. Let's see what voltage we see on the... what? That's not right. I think my battery of my multimeter is dying. There we go. That's probably better. So minus and plus. Yeah, right. Output of the power supply. Although we're doing 100 amps, so that's 500 watts, is 5.056. Perfect. So the voltages we're seeing on the screens is likely just that, voltage drop on the cables. We're currently drawing 576 watts from the socket. That's actually pretty low for providing it's providing 500 watts, not 600 watts. Yeah. Okay, sure. That's decent. I mean, there's always going to be some loss in the power supply. So, I'm going to clap a few times. I'll edit that out of the video, but then I can find it in the video where to start my hyperlapse. Because keep an eye on that counter, for instance, over here. Once that reaches 30, that means about 30 minutes has passed while running at 100 amps. Oh, and the fan just turned on. It's not quiet, as you can probably hear. But yeah, it's starting to warm up here in this room. But I'll leave it running, and once, let's say this one reaches 30, we'll come back and see if it managed to do 100 amps for about half an hour or not. And I'm actually wondering, because I know MeanWell mentions that some of their power supplies need to be screwed into metal plates. Now this one has the bottom fully isolated. That might not be ideal. So I'm actually thinking I'm going to prop it up with a screwdriver below it, so it sits just a little bit higher, so the back surface isn't flat to the table. And I'm going to leave it running now. See you in about 30 minutes. Right. Well, as you can see, we're now at 29, and I believe they're all at 29 just to prove that they've all been running. Let's see here. Oh, this one is 28. And this one is at 28. Fine. I just did a FLIR shot. For that, I put a little bit of black tape on here because you can't FLIR a metal part. And as you can see, the fan seems to be doing its work quite well because internally it was about 45 degrees or so. Over here, internally, it seemed like there's quite some hot spots, but there's some caps there. I'm not sure what's in there. I don't know. But it's been running for half an hour. It's still only drawing 580 watts from the socket, so it's not like runaway in regards to power there. And voltages have remained very stable. It's certainly warmer hot to the touch. I can touch it and keep my hand on there, but the bottom side is certainly also warm, and that actually stings a little bit if I keep my hand on there. So when mounting these, if you're truly going to use that much power, make sure they're not flat on a surface, because then the heat can't radiate away. So that's what I did with my little screwdriver under there. Let's turn that off. Let's see when the fan turns off. We're at 60 amps now. Fan is still on. 40 amps. Fan is still on. 20 amps. Noise became less. 0 amps. Okay, the fan's turned off. My loads are still going because they still need to cool down, but the fan stopped pretty quickly once the load was gone. Yeah. Well, I can only give you the conclusions I know so far, and that is that this is one from AliExpress. As I said, I'll have everything linked in the description. And, well, it did 5 volt 100 amps for at least 30 minutes, and voltage remained perfectly stable, no problem whatsoever. So, as far as it goes, sure, that's definitely recommended so far. But let's do a conclusion at the end. I'm going to replace the 5 volt one with the 12 volt one, and then we're going to see if we can load it up to 50 amps. So that's about 600 watts, and well, then it's going to run again. This room certainly has become a lot warmer than when I started. So, let me change that around. Right, that is all wired up. Let's fire it up. Let's turn on the testers first. There we go. They're kind of moved. Something like that. Let's plug it in. And go. Seems okay. We've got the green light, and, well, as expected, we're seeing 12.09, 12.86, 12.9, 12. Oh, this one again is slightly higher, so maybe its measurement is just slightly differently calibrated. And 12.08, that's fine. We'll do a check on the terminals once that's running. So we have about 600 watts. So if we do 10 amps at 12 volts, that is about 120 watts per tester. So if we do that times 5, nope, well, let me get the button here. that should give us our 600 watts. So that is 20 amps. Okay. This one's missing a foot. Oh, don't do it. Okay. Sure, let's just, load it up immediately. Okay. Voltage seems very stable. Again, that's good. And now if we look at that, this is 120 watts, 240 watts, 360 watts, 480 watts, and 480 watts plus 120 is 600 watts. That's pretty good. Let's try and mangle this cable a little bit. There we go. Where's my multimeter? Let's see what it says. Okay. It says we're doing 12.09 at the terminals while loading it with 50 amps or 600 watts. That's pretty good. That's fine. That's perfect, actually. Well, I'm not going to bore you much longer. We're going to do exactly the same thing. When this timer on one of them reaches about 30-ish or so, we'll stop the test, and then it'll have survived 30 minutes at a real-world maximum load. So, see you guys then. We're back. It's been, well, I'm calling it. It's been 30 minutes. I think this one, the 12 volt version, actually stays slightly cooler. Not by much, but it's okay. I forgot to mention how much is drawing from the wall. It's drawing 670 watts from the wall. Okay. Voltage has remained stable all this time. No weird things going on. So yeah, let's just turn it off. Yeah. Okay. Don't put your don't put your hands in the fan. Okay. All loads are off. Fan is still going. Let's wait for that to die down. It's drawing 9 watts from the wall now. Let's see what it goes down to. 9.44 watts from the wall. Let's see what it goes down to when the fan is off.
Infinite power.
All loads have cooled down, so that's a little bit less noise, but this one certainly is making more noise. Wow, okay, that's taking much longer than I expected. The 5 volt one basically turned off in a few seconds of the load being removed. Okay. Let's wait for a little bit longer. Well, I guess while we wait for that, we can take a look at, I don't know, we can compare a LRS-600-5 to, what's this? I can take the other one. Oh, so this one does 100. My AC cords are stuck. Oh, fan turned off. Well, I'm going to continue with this now anyway. There's too many power supplies here. Ugh. So this is the LRS-600-5, which does 100 amps, but is, actively cooled. I also have this the wires, they're not liking me today. There we go. I also have this UHP dash 505. So this does 80 watts or 80 amps, and this does 100 amps at 5 volt. But this one is fully passive. It's a bit more expensive though, but it also has an active PFC and it has all kinds of potting inside, and it's a really, really nice power supply. So if you need 80 amps, 5 volt passive, this is your guy. I mean, that's awesome. But if you don't mind the noise, or you're actually going to build it in an enclosure where you kind of need a fan, passive power supplies don't work that well in enclosures. Yeah, this one performed like a champ too. So let's... I heard something disconnect. I don't know what it was. Let's do a little bit of conclusion here, because I think, well, from this limited testing, but still, these were actual full load tests here. Both, let's turn it off, shall we? Both the LRS-600-12 and LRS-600-5 did excellent. As I said, I bought these on AliExpress. I don't know if they're fakes, but if these are fakes, they're the best damn fakes I've ever seen. I don't think they're fake. I think they're real. And they handled everything like a champ. Didn't get too hot. Ran maximum rated load for at least half an hour. Voltage didn't budge. Excellent. I don't have anything else to say. We even took FLIR shots. One test I thought of I could do maybe is dead short it. I don't really want to do that because I actually want to use these power supplies in the future. And if you dead short something too often, it can actually damage it, although it's protected for that. And I recommend using this kind of stuff, especially like 100 amps and stuff like that. It fuses anyway. So yeah, I'm pretty sure that from previous experiences with MeanWell power supplies, if you dead short it, it'll just go into hiccup mode. And okay, should we do it? I guess we should do it. I don't know. I'll buy new ones if it breaks. But what am I going to dead short 100 amps with? I mean, what? Let me think about that for a second while I unscrew this cable. I guess we're going into overtime bonus content. I hope so. Let me turn the loads off. Right, so. Oh, we can do another comparison real quick. Because I have another 5 volt power supply, which is actually my biggest 5 volt power supply. And that is this guy. This is the HRP. Come on. There's too many cables here. This is the HRP 600-5. That does 120 amps at 5 volt. But the LRS one didn't exist. The LRS-600-5 didn't exist when I bought this one, because this one's even more expensive. And it has some bigger terminals, so that's nice. But this one's likely going to be very cheaper, and they both have a fan, because this one has a fan over here. So they're about the same noise. You can get this one with slightly more advanced features, but generally for driving LEDs you don't really need or use that. So, and having used this one a lot, and the UHP one, and now this one, I'd say in regards to output quality, I haven't put a scope on them yet, but I think they're about the same. The UHP one I really like, because it's passive and massive amounts of power. So, yeah. Let me get some stuff out of the way here. So, how do you dead short 100 amps? I don't know, man. Let me get a cable and we'll see. Let me arrange this stuff on my desk here. Okay. Go away. I don't want anything close when I do this. Right. Okay. Okay, let's start with the 12 volt power supply. Let's get you the top-down view. Right. And I have some giant cable here. This is, what is this? I think this is 8 gauge. Yeah, this is 8 gauge cable. I mean, what do you want from me? I think I might actually be able to fit this ring on here. So, okay, it's off. That's good. Let's take the middle terminal. Let's get the screw out completely. And let's screw in the red one. Can I make it fit? I think I can make that. I'll just have to squish it in there a little bit. It's not a problem. So that's at least going to make a very good connection. Let's get the black one out of the way. Oh, no. Don't do that. Don't rip the cables. When separating silicone cable like this, it's often a good idea to actually cut it in the middle, like so, because that gives you a very clean split. And if you tear them apart, it sometimes tears it the wrong way. So, okay, we can keep the black one out of the way, and we're going to be touching this terminal here. Okay, let's see what happens first if we start it up while touching it, right? So let's apply power. It's drawing 95 watts from the wall, 92, and now it's drawing nothing. Green light turned off. Let's remove the short. Did I kill it? Is it dead? It's drawing 0.5 watts from the wall. Let's turn it off. Turn it back on again. It might be dead. Well, now, that was a quick test. Huh. Interesting. Now, I don't know if there's a fuse inside of here. There's not one that you can see or reach. So I'll have to open it up at some point and see. But there's AC inside, so I don't really like that. But it's dead, Jim. Let's leave it off for a little while longer, okay? Let's, allow it to reset or something. Please reset. You were expensive. So, yeah, fuses. Use fuses everywhere. Okay, that's long enough. Let's try it one more time. Nope. No, it's dead. It's yep, that's not going to work anymore. One thing I can try and see if it's actually the fuse in my power meter. I don't think so, but you never know. So let's replug that. Nope. Okay, that's one LRS-600-12 that's dead. Yeah. Yeah. So, anyway, how's your day going? Damn it. Okay. There's no visible damage, and I'm pretty sure it's likely an input fuse, or it wasn't inputting that much. It was 93 amps. So, not sure what that would have blown. One more time. Nope. Nope, it's dead. Okay. Okay. Well. Now, the smart thing to do would be to not kill the other one. But then you don't know me well enough. Because of course we're going to try the same test on the other one now. So this time I'm not going to attach it while booting. Although it should be able to survive that just fine. I mean, there's no reason that should kill it. Please. I guess I can now use one of those YouTube the video descriptions, I killed my LRS-600 or something like that. I don't know. Okay, so we have it screwed into the positive terminal and we're going to touch a negative terminal. This time though, I'm going to do it while it's live. So I'm going to turn it on and then touch it like that. Now, let's put on the safety glasses. I should have done that before, you know, but let's do it. This will give some spark, but sparks are dependent on the voltage. This is the 5 volt, so it'll be less sparks than, for instance, the 12 volt would have given. But it's dead. Okay, we've got a light, so let's touch it. 129 watts, 268, oh, and smoke. But the smoke is from the terminal, because it's probably welding. Oh, well, the smoke, I think, was from the terminal. But it's dead. Okay, let's turn it off. That's like 250 euros down the drain in 5 minutes. You know, somebody's got to do these tests. So let's leave it off for a little while. It wasn't drawing a huge amount of current. It was drawing like 200, maybe 300 watts at max. So, I mean, it's while testing it, drew, I don't know, 570 watts. So it's not like it's an exorbitant amount of inrush current from the AC side, at least. So, yeah, I'm not sure what's going on. See if it turns on. It does not. Yeah, it's dead, Jim. Just like we know it. Not any other way. Okay. Well, somebody needs to do these tests, it seems. I don't know if this is a design flaw or something else is going on. But from everything I've ever seen, a MeanWell power supply can survive a dead short just fine. And I was joking about being a clone before, because, well, if this is a clone, this is the best clone I've ever seen, basically. So I don't think it's a clone. Yeah, it's dead. They're both dead. They're all dead. So, we are still going to end this video here, because, well, there's enough footage already. Conclusion time. They handled their rated loads like a champ. They were very stable, and my cables are a mess in the office right now, but they both handled the load excellently, didn't overheat, voltage was very stable, didn't see any ripple or anything. It didn't hook it up to a scope, but, you know, they were perfect until you dead short them, and then they die. I'll probably do a live stream or another video opening these up. Be careful, there's AC capacitors inside, those can kill you. So it'll probably be a little while before I have time to do that. But, yeah, that kind of sucks. Because, other than that, I really like them. So, if you run a setup, and we'll talk about more later, like in the future, when you need 50 or 100 amp power supplies for maybe something I'm designing, use fuses. Always use fuses. Your power supply will either happily supply current to put stuff on fire, or just die. And these are like at least $100 a piece. If anything, yeah, learned that today. Other than that, I think they're still good power supplies. I don't know why they died, though. So maybe if MeanWell is watching this, can you explain what happened? Because, well, I'll check the data sheet again, but it should either have overcurrent protection, an input fuse, but the input fuse, I don't think it blew because it never drew that much power. So then, what died? Maybe we can find out at some point. And I hope you'll be there. Thanks for watching. Bye-bye. Hey guys, it is now the next day, and I was editing this video, and even the night before, before I went to bed, I was like, I find it kind of impossible that I actually killed this thing. So before going to bed, I went back into my, my garage studio, and I turned it back on. And guess what? Let me do that right now. It turns on just fine. So, I talked about this on my Discord server in my Quinn Knowledge Build channel, where I share a bit more stuff. And one of the guys said, oh wait, in the datasheet it says you need to give it at least 4 minutes for it to reset. Well, I thought I gave it plenty of time in the video. I guess not. But just to make sure, this is the 600-12 variant. Let's hook up all the testers again, draw 50 amps, see if it does that for a few seconds, and then it's likely just fine. So let me hook that up and test that real quick, and then we'll make a new conclusion, I guess. Because, well, I don't want to fault this thing if it's not broken. I mean, then it did its job, right? So let me hook that up. Okay, all hooked up. Let's turn on the testers. Let's get them in a shot, something like that. Okay, let's see, this is all positive, this is all negative. I made a boo-boo in the beginning. Okay, let's start it up. Yep, it's still providing 12 volt like it should. Okay, let's not drag this out. No. 10 amps. 20. 30. 40. And 50. See if it's in the shot. I think so. Yep, it's drawing 665 watts from the wall. Voltages seem fine across the board. Well, that's more than enough for me. This power supply, and I'm not going to test the other one because I tested it and it turned on fine. This power supply is perfectly fine. So, new conclusion then. The overcurrent protection actually works. It just works a little bit different than I'm used to. I'm used to power supplies going either into hiccup mode or turning off, and then you can turn them on again in a few seconds. But with this version, I guess it really needs like 4 or 6 minutes, something like that, to reset the circuitry that was preventing input or output. I did actually open one of them up. I tested the fuse that was in there. That wasn't the problem. Of course, that's the input fuse, and we never saw, as I mentioned before, a huge input spike. So there's nothing wrong with it. There's just a circuit in there that prevents you from overloading the power supply or dead shorting it. And if you do, it just stays off for a very long time. And after that it resets, and it's perfectly fine. So, it handles the load perfectly. We just loaded it again, no problem. And it has good protection circuits in there too. So, let that be the new conclusion, please. Let's forget the other one. I mean, the lesson from the other one is still valid. Use fuses where you can. It's important. But at least this power supply, you won't kill. You might set something else on fire, but you won't kill this power supply. So that's a good thing. Recommended by me, of course. I've been recommending all kinds of MeanWells, so that's no surprise. But affiliate links will be in the description, and I mean, YouTube's going to bury this video for how long it is. But if you're still watching and you found it valuable, using those is very much appreciated. And let me know down in the comments what you thought when it wouldn't boot up anymore. Okay, thanks for watching. Catch you guys next time. Bye-bye.